functions. A relation from set A to set B is said to be a function if every element of set A has only one image in set B. That every element of A should have a unique image in set B. Then it is called a function. So a relation becomes a function only when this definition is satisfied. So I can say that all functions are relations, but all relations cannot become functions unless the definition is satisfied. That is, for every element of set A, there should be a unique image in set B. Let us consider this example. Let A be 1, 2 and set B be 3, 4. So the Cartesian product of these two sets will have 4 elements: 1, 3, 1, 4, 2, 3 and 2, 4. Now we know that every subset of this Cartesian product is called a relation. Let us consider a relation set of all x, y such that y is equal to x square, where x belongs to the set A and y belongs to the set B. So we know that this has only one element. Square of 2 is 4. Look at the arrow diagram. A has 2 elements 1 and 2. Set B has 2 elements 3 and 4. So 2 is related to 4. This is not a function. The reason is the element 1 doesn't have an image. According to the definition, for every element of set A, we should have a unique image. 1 doesn't have an image, therefore it is not a function. Let us consider another example. Set of all x, y such that x less than y, where x belongs to the first set A and y belongs to the second set B. Let us write the elements in rooster form. So the elements are 1, 3, 1, 4, 2, 3 and 2, 4. All 4 elements we have. Let us see the arrow diagram for this relation. One is related to 3, 1 is related to 4, 2 is related to 3, 2 is related to 4. This is also not a function. Here the reason is, let us consider this element 1. So 1, 3 and 1, 4. 1 has 2 images, 3 as well as 4. Each element should have a unique image. But here every element has 2 images. Therefore, it is not a function. The definition of function is not satisfied. So it is a relation, but it doesn't become a function. Let us consider another example of a relation from the given A cross B set. Set of all x, y such that x is greater than y, where x belongs to the first set A and y belongs to the second set B. If you write it in the rooster form, it is a null set. Consider the arrow diagram. So this is also not a function because the elements 1 and 2, they don't have images at all. So it is not a function. Let us consider another relation R. Let me write it in rooster form. 1, 3 and 2, 3. A is 1 and 2, B has 3 and 4. 1 is related to 3, 2 is related to 3. Is this a function? Yes, it is a function. If you see, the element 1 has only one image 3 and element 2 also has only one image 3. They are sharing one image. That is not a problem. but every element of set A has a unique image in set B. Therefore, this is a function. Now see definition 6. A function which has either R or one of its subsets as its range is called a real valued function. So a real valued function means the range of this function should be a subset of R, real number set. Then it is called a real valued function. Now real function means the domain should be a subset of R. Then we call that as a real function. We are going to learn about few important functions. First function, we are going to learn about identity function. Let us consider f from R to R, defined as y is equal to f of x is equal to x itself. This is an identity function. That is, if x is 0, y is 0. If x is 1, y is 1. If x is minus 1, y is also minus 1. For 2, we get 2. For minus 2, we get minus 2. Let us draw the graph of this. X-axis, y-axis. Let us plot the points 0, 0, 1, 1, 2, 2, minus 1, minus 1, minus 2, minus 2. Let us join these points. Y is equal to x line, which is an identity function. Let us see the domain and range of this function. Domain of this function is x can take any real value, and range is also R because y is equal to x. Whatever x value is, y takes the same value. So domain is R, range is also R. Now let us learn about constant function. This chapter is an important chapter. We have continuation of this lesson in 12th standard, and we use functions in so many lessons. Let the function f be from R to R. Y is equal to f of x is equal to some constant c. Let me take c as 2 here. So y is 2 always. Whatever the value of x is, y takes the value 2. X can be 0, 1, minus 1 or 2, minus 2. Any value x can take, but y is always 2. Let us draw the graph of this constant function. Plot the points 0, 2 is this point, 1, 2, minus 1, 2, 2, 2. Let us join these points. This is the graph of y is equal to 2 line. So y is equal to a constant will represent a straight line which is parallel to x-axis. Let us see the domain and range of this function. So domain, x can take any real value, so the domain is R, but range is 2. It is a set. Domain and range are sets. So for all real values, you have infinitely many real values. For all real values, you have only one image. That's why this is called a constant function. So the range has only one element. Let us do a vertical line check. If you draw a vertical line, if it cuts the graph at only one point, then it is a function. This is called a vertical line check. We can check from the graph by drawing a vertical line. If you draw anywhere, if it crosses the graph at one point, then it is a function. Let us learn about polynomials. Polynomial function. What is a polynomial? An expression of the form a0 plus a1x plus a2x square, etc. an x power n, where a0, the coefficients a1, a2, etc. up to an are real numbers. And this becomes a polynomial only when powers of x are positive integers. Negative powers or fractional powers are not called polynomials. For example, if you have 2 root x plus 3, this is not a polynomial because x power half, it has a fractional power. So it is not a polynomial. Now 1 by 2x plus 3. This is also not a polynomial, or 1 by x, because this is x power minus 1. Negative power. This is a rational expression. We call them as rational expressions. So negative powers for x and fractional powers for x are not allowed in polynomials. We will draw a graph for a very simple quadratic polynomial. Let us consider f from R to R. I am taking a quadratic polynomial. Y is equal to f of x is equal to x square. Let's draw the table for this. If x is 0, x square, 0 square is 0, 1 square is 1, minus 1 square is also 1, 2 square is 4, and minus 2 square is also 4. Let's draw the graph. X-axis. Very simple quadratic function has been taken. You can have quadratic expressions like this, x square minus 3x plus 2. But I have taken a very simple quadratic function, y is equal to x square. Let us plot the points. 0, 0, 1, 1, and for 2 it is 4. And for minus 1, 1, for minus 2 it is 4. Only a linear function represents a straight line in the graph. For quadratic functions, we have to draw a freehand curve. It passes through the origin. A quadratic function represents a parabola. Now, whether it is a function or not, we can easily check by drawing a vertical line. See, if I draw a vertical line, if it cuts the curve at one point, then it is a function. For example, let us consider this parabola. And let us check by drawing a vertical line. It cuts the graph at 2 points. Therefore, this is not a function. Because for one value of x, we get two answers of y. Therefore, it is not a function of x. Let us see the domain and range of this function. Domain of this function is x can take any real value, so domain is R. But range, f of x values, x square, I can say that x square is always positive, and it can be 0 also. If x is 0, x square is 0. So it takes values from 0 to infinity, including 0. Okay, let us learn about one more polynomial, a cubic polynomial. we will take f from R to R, and a very simple cubic polynomial we will take, which is y is equal to x cube. If x is 0, y is 0. If x is 1, y is 1 cube. Minus 1 cube is minus 1. 2 cube is 8. Minus 2 cube is minus 8. Let us plot these points. X-axis, y-axis. Let us plot these points for cubic polynomial. 0, 0, 1, 1, minus 1, minus 1. For 2 it is 8, and for minus 2, minus 8. This is minus 6, minus 7, minus 8 will be here. Let us draw a freehand curve. This is the graph of y is equal to x cube. Let us discuss the domain and range for this function. Domain of this function, x can take any real value, so R. Range is also R. It can take positive value, negative value, 0, so range is also R. Let us do a vertical line check. If I draw a vertical line crossing the graph, it crosses the graph only at one point. Therefore, this is a function. So to check whether the graph is a function or not, we can do vertical line check. Next, let us learn about rational function. Rational functions are functions of the type p of x divided by q of x, where q of x is not equal to 0, because denominator cannot become 0. And p of x, q of x both are polynomials. Let us consider a very simple rational function. Y is equal to f of x is equal to 1 by x. Here numerator is a polynomial of degree 0 and denominator is a polynomial of degree 1, and x is not equal to 0. Let us draw the table. X cannot take the value 0. If x is 1, y is 1. If x is 2, y is 1 by 2. If x is 4, y is 1 by 4. If x is half, y is reciprocal of half, which is 2. And if x is 1 by 4, y will be 4. Let us take negative values. For minus 1, it is minus 1. For minus 2, minus 1 by 2. That is minus half. And for minus 4, it is minus 1 by 4. And for minus half, it becomes minus 2. And for minus 1 by 4, it is minus 4. Let us draw the graph of this function. X-axis, y-axis. Let us plot the points. For 1, it is 1. For 2, it is half. For 4, it is 1 by 4. And for half, it is 2. And for 1 by 4, it is 4. Let us draw the graph. The graph should not touch x or y axis. Now let us plot the negative values. For -1 it is -1, for -half it is -2, and for -1/4 it is -4, and for -2 it is -half, and for -4 it is -1/4. Let us join these points. The graph doesn't touch either x-axis or y-axis. We say that x and y-axis are asymptote to this curve, and the graph is discontinuous at x is equal to 0. There is no value for y when x is 0. Therefore, the graph is discontinuous at x is equal to 0. Let us see the domain and the range of this function. So, domain is equal to, it can take any real value but not 0. And range, 1/x cannot take the value 0. Other than 0, it can take any real value. Therefore, the range is also r minus 0. You can draw a vertical line and check. It will intersect the graph at one point. Therefore, it is a function of x. Let us learn about modulus function. Let f be a function from R to R, real number set to real number set, and y be defined as f of x is equal to modulus of x, or absolute value of x. The definition of absolute value of x is, it will be x when x is greater than or equal to 0, and it becomes minus x when x is less than 0. Absolute value of 5 is 5. If it is positive, the number is the same. If it is a negative value, it is minus of minus 5, which becomes plus 5. So the answers are always positive. Let's draw the table for this function. If x is 0, absolute value of 0 is 0. Absolute value of 1 is 1. For 2, it is 2. For 3, 3. For minus 1, it becomes plus 1. For minus 2, it becomes plus 2. For minus 3, it is plus 3. Let us draw the graph of this function. X-axis, y-axis. Let us plot the points 0, 0, 1, 1, 2, 2, 3, 3. For minus 1, it is plus 1. For minus 2, it is plus 2. For minus 3, it is plus 3. Let us join these points. This is a ray, which is y is equal to x, and this is y is equal to minus x. Absolute value of a linear function always takes V-shaped graph. And if you notice, y cannot be negative here. That's why we don't have graph in the negative part of y-axis. We should not extend these lines because y doesn't take negative values. The domain for this function, x can take any real value, and range, but the answers are all positive values, we know. So it takes only positive values. If x is 0, it can take the value 0. So the answer is closed at 0 to infinity. This is the range of this function. If you draw a vertical line, it cuts the graph at only one point. Therefore, it is a function. Next, let us learn about Signum function. These three functions are very important: absolute value function, Signum function, and greatest integer function. They may ask you to draw the graph of these functions, and we use these functions in other lessons as well. Signum function, let f be defined from R to R. Y is equal to f of x is equal to, it is defined as 1 when x is greater than 0, and it takes the value 0 when x is equal to 0, and it takes the value minus 1 when x is less than 0. This is one definition of Signum function. Or you may define Signum function as absolute value of x by x when x is not equal to 0, and it takes the value 0 when x is equal to 0. Both are Signum functions only, because absolute value of x by x, if x is positive, absolute value of x is x itself, so the answer becomes 1. Whereas if x is a negative value, say, absolute value of x is minus x by x, so the answer becomes minus 1. So we may define Signum function like this or like this. Now let us see the arrow diagram for Signum function. For all positive real values, how many positive real values are there? Infinitely many. For all positive real values, the answer is plus 1. For 0, the answer is 0. And for all negative real values, how many negative real values are there? Infinitely many. For all these values, the image is minus 1. If you see the domain of this function, x can take any value, so R is the domain. And think about the range. Range has only 3 answers. It can take minus 1, 0 or 1. Only 3 elements are there in the range. Codomain is R, but range has only 3 elements, minus 1, 0 and 1. Let us draw the table for this function. We will take few positive values and few negative values. For 0, the answer is 0, we know, according to the definition. For positive real values, the answer is 1. For negative real values, the answer is minus 1. Let us plot these points. X-axis, y-axis. Let us plot the points. 0, 0. 0, 0 is one part of the graph, and for 1 it is 1, for 2 it is 1, for 3 it is 1. Let us join these points. Similarly, for minus 1 it is minus 1, for minus 2 minus 1, for minus 3 minus 1. For 0, the answer is 0, so we have to draw a bubble here. Similarly, the answer is 0, not here, so we have to draw a bubble. Let us join these points. This is one part of the graph. 2 rays are there, and this point, 0, 0 point is also there. 3 parts are there in this graph. One part is this ray excluding this point, and 0, 0 is the another part of the graph, and here excluding this point, this ray. So 3 parts are there in this graph. Now let us write the domain and range of this function. Domain. X can take any real value, so domain is R. But the range is, as I said, we have only minus 1, 0 and 1, 3 elements. Next function, greatest integer function. Let f be from R to R. Y is equal to f of x is equal to greatest integer function of x. It is written within square brackets. What is greatest integer function? This function gives the greatest integer which is less than or equal to the number. For example, the greatest integer of 2.5 is 2. The answer which you are writing should be lesser than or equal to the number. It cannot exceed the number. So 2.7 is also 2. 2.99 is also 2. We don't round it off. Don't write the answer as 3 because the answer 3 is bigger than this number. But definition of greatest integer function is the answer should be less than or equal to the given number and it should be an integer. Okay, greatest integer function of 2 is 2 itself. And when you write greatest integer function for negative values, you have to be very careful. Minus 2.5, the greatest integer function becomes minus 3. Because on the number line, minus 2.5 is here. You have to give the answer as an integer which is lesser than the given number. So minus 3, it is not minus 2. Similarly, for minus 2.9 also we get minus 3. Now, if you consider all real values between 0 and 1, including 0, excluding 1, the answer will be 0. And for all real values between 1 and 2, including 1, the answer will become 1. Because for 1.1 it is 1, 1.2 the answer is 1, 1.9 also the answer is 1. But for 2 the answer is 2, etc. Similarly, on the negative part, for minus 1 to 0, including minus 1, the answer becomes minus 1. And for minus 2 to minus 1, excluding minus 1, the answer becomes minus 2. Let us draw the graph of this function. X-axis, Y-axis. For all real values between 0 and 1, the answer is 0. But for 1, the answer is 1. So we have to draw a bubble at 1. For 1, the answer is here 1. And for all real values between 1 and 2, the answer is 1. And for 2, the answer is 2. And for 3, the answer is 3. Similarly, on the negative side, for all real values between minus 1 and 0, the answer is minus 1. For 0, the answer is 0. So I have to draw a bubble at that point. And then for all real values between minus 2 and minus 1, the answer is minus 2, except for minus 1. Then for all real values between minus 3 and minus 2, the answer is minus 3, except for minus 2. So if you notice, if you see this function, it is discontinuous at all integers. So many breaks are there in the curve. So at all integers, the graph is discontinuous. It's like steps. Domain of this function. It can take any real value. So domain is R. But if you see the range, the answers are all integers. So only integers are answers, therefore the range is Z. Now let us learn algebra of real functions. We have already learned in lower classes addition, subtraction, multiplication and division of real functions. F plus g of x becomes f of x plus g of x. Similarly, for minus, f minus g of x will become f of x minus g of x. And then for multiplication, f into g of x will be f of x into g of x. Similarly, for division, f by g of x is f of x divided by g of x. And we have a condition here, g of x should not become 0. And we can multiply a function by a scalar quantity, alpha into f of x. Alpha is a constant, so it can be written as alpha times f of x.